non-homogeneous partial differential equations. In all sums, there will be factors d and d dash. Factors like this: d, m d dash minus c of z equal to 0. The factors are in the same, we have to consider the same shape in doing the sums. See, dou z by dou x minus m, dou z by dou y, dz is dou z by dou x, d dash z is dou z by dou y, minus cz equal to 0. This is p equal to dou z by dou x, small q equal to dou z by dou y. So, applying in this, small p minus mq minus cz equal to 0. P minus mq equal to cz. We have to use Lagrange's PDE in this step, initial step. By fixing a regular step, we are doing all non-homogeneous differential equations. Lagrange's equation is PP plus QQ equal to R is the Lagrange's PDE. Lagrange's PDE. In Lagrange's PDE, dx by capital P, dy by capital Q, dz by capital R. This is all standard. We are going to see Lagrange's PDE later parts, later stages. Dx by comparing these two, capital P is 1. Dy by comparing these two, capital Q is minus m, where capital P, capital Q, capital R are functions of x, y, z. Dz by of cz is a Lagrange's type of solving the sums, and taking first and second members, ds by 1, dy by minus m. M take this side, m dx equal to minus dy. Integrating mx equal to minus y plus c1 constant, y plus mx equal to c1. We have to find two constants, c1 and c2. By taking some other two steps, members, we can find c2. Taking first and third members, dx by 1, dz by cz, c bring this side, c dx equal to dz by z. Integrating cx equal to log z plus log k1. There is a constant. We have to, whenever integrating indefinite integral, we have to use constant. Log take is log k1 is a constant. Therefore, log of zk1, bring this side, log of zk1 equal to cx we must know one thing, log of e power x equal to e power log x equal to x. It is always we will use, frequently we are using for all sums. Taking exponential on both sides, e power log of zk1 equal to e power cx. zk1 equal to e power cx. z by e cx equal to k1. z by equal to 1 by k1. Let us take again dx by 1 dz by cz. c dx equal to dz by z. Integrating cx equal to bring this side dz by z equal to c dx. Integrating log z equal to c x plus k2 k1. Raising to exponential form like this, e power log z equal to e power cx plus k1. z equal to e power cx e power k1 separated into 2. z by e power cx equal to e power k1. This is a constant. It can be changed as another constant c2. z by e power cx equal to c2. Therefore, by Lagrange solution is f of c1 comma c2 equal to 0. Already we know c in y plus mx. c2 is z by e power cx. This is the Lagrange solution. This can be written as two functions are there. One can be written as another function. Let us take outside e power cx. This can be written as phi 1 of y plus mx. This also answer. This is answer c1, c2. This also answer. We are writing in Lagrange's PDE. C cross z equal to e power cx phi 1 of y plus mx. This is standard step we are using in the non-homogeneous partial differential equations. Z equal to, this is called CF. CF equal cooperative function equal to e power cx phi 1 of y plus mx. This is permanent to all sums. This should be, it can be taken as complementary function. Now let us enter into solving sums. Solve first sum. Solve d plus d dash minus 1 d plus 3d dash minus 2 of z equal to e power 2x plus y plus xy. Let us take, there are three factors, 1, 2, 3. Let us take the first factor, d equal to 0. See, d minus md dash minus c equal to 0. This is the form we have to take as one factor, standard factor. Comparing this to d minus 0 d dash minus 0 equal to 0. Comparing this to m equal to 0, c also 0. Therefore, what is CF1? E power cx 5 y plus mx e power 0x 5 y plus 0. Therefore, 5 y is the first complementary function. CF1 equal to 5 y. Let us take the second factor, d plus d dash minus 1 equal to 0. Compare this, d minus m d dash minus c. This is standard factor, standard results. What is m? Comparing this to minus 1. Comparing this minus 1. C equal to 1. Writing this, CF2 equal to e power cx 5 of y plus mx e power 1x 5 of y minus x. M is minus 1. Therefore, CF2 is e power x 5 of y minus x. And let us consider the third factor, d plus 3d dash minus 2 equal to 0. Compare this, d minus md dash minus m equal to 0. Compare this to m equal to minus 3, d equal to c equal to 2. C equal to 2. CF3 equal to e power cx 5 of y plus mx e power cx 2x 5 of y minus 3x. CF3 equal to e power 2x 5 of y minus 3x. CF1, CF2, CF3. Again, we have to find particular integrals, two particular integrals, pi1, pi2. Let us first take pi1. E power 2x plus y divided by d plus d dash plus d plus 3d dash minus 2. Wherever d comes, you put coefficient of 2. For d dash, coefficient of x, coefficient of 1, y, which is 1. Therefore, e power 2x plus y divided by 2 plus 1 minus 1, 2, 3 minus 2. E power 2x plus y divided by 2 into 2, 3. E power 2x plus y by 12. P1 equal to e power 2x by y by 12. Again, we have to find particular integral 2. That is bigger one. Pi2 xy d plus d dash minus 1 d plus 3d dash minus 2. xy by d biggest bracket, in ID take out 1 minus d minus d dash. In this, put a big box bracket, 2 taken out, minus 2 taken out, 1 minus d by 2 minus 3 by 2 d dash. This minus plus, therefore 2d xy divided by 1 minus d dash, 1 minus d by 2 minus 3 by 2 d dash. Equal to 1 by 2d. These two factors should be taken up. 1 minus d plus d dash whole power minus 1. This also 1 minus d by 2 plus 3d dash by 2 whole power minus 1 of xy. Let us do binomial expansion for this. 1 minus x whole power minus 1 is 1 plus x square plus etc. Applying this binomial 1 by 2d, 1 minus d plus d dash whole power minus 1, 1 plus d by 2, 3 d dash by 2 plus x square d by 2 plus 3 d dash by 2 plus etc. of xy whole square. Equal to 1 by 2d, 1 minus d plus d dash whole power minus 1. This is expanded and removing the bracket, d by 2 plus dd by 2 plus d square by 2 plus 2 into d by 2, 3d dash by 2 plus 3d dash by 2 whole square plus etc. Primitive of xy. 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 1 by 2d of 1 minus d plus d dash whole power minus 1, 1 plus d by 2, 3 d dash by 2. D square is not necessary because we are integrating differentiation twice is 0. One time only x integrable, differentiable. Therefore, this is not necessary. This 2 to get cancelled. 3d d dash by 2. This is also not a d dash square. Not it becomes 0 when differentiating of xy. 1 by 2d 1 minus d plus d dash. See, you bring inside xy. D by 2 means differentiation of with respect to x only. If differentiate with respect to x only, y only comes. Therefore, y by 2 differentiate with respect to y only. 3 by 2 x, 3 by 2 x plus dd dash of xy. Differentiation of y is 1 x, which is 1. Therefore, 3 by 2 into 1 equal to 1 by 2d 1 minus d plus d dash whole power minus 1 of xy plus y by 2 plus 3 by 2x plus 3 by 2. Now let us expand this. Same 1 minus x whole power minus 1. You consider this be x, 1 plus x square plus x cube. 1 by 2d of 1 plus d dash square plus the maximum square enough. This is only maximum 2 times only coming, not square times coming, xy only coming. Therefore, xy plus y by 2 plus 3x by 2 plus 3 by 2. 1 by 2d 1 plus d, remove the bracket, d plus d dash in this d dash square plus 2 d dash plus d dash square. d dash, d square, d dash square not necessary. Of xy plus y by 2 plus 3x by 2 plus 3 by 2. Removing d square and d dash square. 1 by 2d 1 plus d dash plus 2d dash of xy plus y by 2 3x by 2 plus 3 by 2. 1 by 2d. Now bring 1 by 1 inside. 1 into this complete xy plus y by 2 3x by 2 plus 3 by 2. And d means differentiation with respect to x only. X means 1, y. Here x is there, 3 by 2. D dash is differentiation with respect to y only. Here y is 1, x. Here y is there, 1 by 2. 2 d dash of xy, d dash for all this 0, but xy only become 1. Just I have written already, d dash is 1. d dash is 1. 2 of d dash what? Here 1. Remaining are will become 0. Therefore, 1 by 2d of xy plus 3 by 2x plus 1, 5 by 2x, y by 2y plus 1 plus 3 by 2y, 1 by 2 plus 1 is 3 by 2, plus constants of 3 by 2, 1 more 3 by 2 plus 1 by 2 plus 2 equal to 1 by 2d of xy 5x by 2 plus 3y by 2, 3y by 2. Quotient of y is 1 by 2, here 1 is 1, 1 by 2 plus 1 is 3 by 2, 3 by 2 plus 1 is 5 by 2, x 5 by 2, and plus 3 by 2 plus 1 by 2 plus 2. I am writing here 3 by 2 plus 3 by 2 plus 1 by 2 plus 2, 3 by 2 plus 1 by 2 plus 2, Take LCM plus 2. LCM is 3 plus 3 plus 1 plus 4. Therefore, 11 by 2. Therefore, plus 11 by 2. See, d comes in the denominator. D belongs to x. Wherever d in the denominator, we have to integrate with respect to x only. 1 by 2 x square by 2 y plus 5 by 2 s square by 2. Integrate 3 by 2 x, just constant means x only, 3 by 2 y plus 11 by 2 x. We have integrated completely with respect to x. Here s square by 2, 5 by 2, here also x square by 2. Here only consider this as a constant. Integration of this constant is only x is there. Integration of only dx equal to x. Similarly, 11 by 2 x. What will you take inside? S square y by 4 plus 5x square by 8 plus 3xy by 2 plus 11x by 2. This is Pi. Let us write general solution. 3xy by 4 here, s square by 4, 5x square by 8, 3xy by 4 plus 11 by 4, 2 comes inside. This is answer. General solution. Z equal to CF1, CF2 plus CF3 plus PI1 plus PI2. CF1 is phi 1 of y. CF2 is e power x phi 2 of y minus x. CF3 is e power 2x phi 3 of y minus 3x. P1 is plus e power 2x plus y by 12. P2 is this plus s square y by 4 plus 5 s square by 8 plus 3xy by 4 plus 11x by 4 is the answer.